Hi everyone, this is Jack from Maths Forge, and in today's lesson we're going to be doing rationalizing surds. So let's take a look at our first example. We have to rationalize 4 over the square root of 7. Now what it means to rationalize a surd is to eliminate any square roots from the denominator. And how we do this is we find an equivalent fraction through manipulation. So how am I going to manipulate 4 over the square root of 7? Well, for the 1-star examples, it's pretty straightforward. If you have the square root of 7 as a denominator, you're going to want to multiply this denominator to the top and bottom of the fraction. So we're going to have multiplied by root 7, multiplied by root 7. And I'll show you what this does. We have 4 times root 7 on top, which is 4 root 7. And then for the denominator, we have the square root of 7 multiplied by the square root of 7, which is the square root of 49. Now we know that the square root of 49 gives us 7. And there we go. If you can see from the question, 4 over root 7, we have managed to rationalize the surd, eliminate the square root at the bottom, and be left with 4 root 7 over 7 through manipulation. And if we check our answer, there it is. Now let's do a 2-star example. Similar to the 1-star example, we're going to multiply the top and the bottom by the denominator. So we have 22 minus 7 root 11 over the square root of 11. And we're going to multiply this fraction here by the square root of 11, top and bottom, and let's see what happens. So because you have an expression on top, you're going to multiply the square root of 11 onto every single term. The square root of 11 on top here that you're multiplying by is going to distribute into both terms. So we're going to have 22 multiplied by root 11, which is going to be 22 lots of root 11, and then we're going to have minus 7 lots of root 11 times root 11. So remember, when you're multiplying the square roots together, you just multiply the roots onto themselves, and it's going to give us the square root of 121, because 11 times 11 is 121. And for the denominator, we're going to have root 11 times root 11, which again is the square root of 121. Now let's simplify this. The square root of 121 is actually just 11. And this goes for the denominator as well. The square root of 121 is 11. So by simplifying these square roots, we end up with the following. 22 root 11 minus 7 times 11, because don't forget the 7 is being multiplied to the square root of 121, which simplifies to give us 11. And then in the denominator, the square root of 121 is just simplified to 11. And we have one final stage of our simplification, this 7 times 11 here. So we end up with 22 root 11 minus 77 all over 11. Now, although I said this was the final step of our simplification, I can actually see one more thing we can do to simplify this further. In the numerator, we have 22 root 11 minus 77, and this is all being divided by 11. Now, I know that 11 can divide into 22, and 11 can divide into 77. 22 divided by 11 will give us 2, and then the root 11 is next to it here. Notice how I just divided the 11 into the 22. Because the 22 is multiplying onto the root 11, you don't need to divide the 11 into both of them. You choose which one you divide it into. And of course, we're going to divide it into the 22 because this simplifies to give us 2. And then we have minus, and don't forget this 11 divides into the 77 as well. So 77 divided by 11 is 7. And this should be our final answer. And if we check our answer, there it is. Now we'll do a 3-star example. So we're being asked to rationalize 3 plus root 2 over 6 minus root 2. Now for the 3-star examples, they're different to the 1 and 2-star examples. You see in the denominator here, we have an expression. So it's not just a standalone single square root. We have an expression, and this is done differently. For the 3-star examples, you're going to want to multiply the numerator and the denominator by the conjugate of the denominator. And I'll tell you what this means. The conjugate is the exact same expression, but instead of a minus in the central region here, we put a plus. So the conjugate of this denominator here, 6 minus root 2, is going to be 6 plus root 2. And you'll see why in a few steps we multiply by the conjugate. So let's go ahead and do that. We're going to multiply by 6 plus root 2 to the numerator and the denominator. So it's the denominator's conjugate. Exactly the same, but instead of a minus, it's a plus. Now let's go ahead and multiply this out. So we have 3 plus root 2 on top. and I'm going to put them into brackets. So I'm going to multiply it onto this expression here, 6 plus root 2. And in the denominator, we're going to have 6 minus root 2 multiplied onto 6 plus root 2, its conjugate. And now if we expand brackets, so we're going to have 3 multiplied by 6, which is 18. 3 multiplied by root 2, which is positive 3 root 2. And then positive root 2 multiplied by 6, which is positive 6 root 2. And positive root 2 multiplied by positive root 2, which is positive root 4. So that's the numerator done. Now we'll do the denominator. 6 multiplied by 6 is 36. 6 multiplied by positive root 2 is positive 6 root 2. Negative root 2 multiplied by 6 is going to be negative 6 root 2. And finally, negative root 2 multiplied by positive root 2 is negative root 4. Now let's simplify this further. You can see in the numerator, the root 4 breaks down into 2, and the two central terms, positive 3 root 2, can be added to 6 root 2. And so for the numerator, we're going to have 18 plus 9 root 2. Of course, the 9 root 2 comes from the 3 root 2 plus the 6 root 2, and then we're going to have plus 2 at the very end here. And before putting the simplified version of the denominator, we actually have to simplify it. So we have a root 4 at the end here, which of course breaks down into a 2. And now this is why we multiply by the conjugate. When you multiply by the conjugate, you end up with these two central terms here, a positive 6 root 2 and a negative 6 root 2. The values are the same, but one is positive and one is negative. And this is achieved by multiplying with the conjugate. So the plus 6 root 2 and the minus 6 root 2 cancel each other out. They give you 0. So we end up with 36, and these two terms have cancelled out, so there's nothing there. But then we have a minus 2. And for the final stage of our simplification, we're going to have, for the numerator, 18 plus 2, which is 20. And it's going to be plus 9 root 2. And for the denominator, we're going to have 34. And since you can't simplify this any further, there are no common factors here that we can divide the top and the bottom by. This should be our final answer. And if we check our answer, there it is. And that's it for the lesson on rationalizing surds. Remember, for the 1 and 2 star questions, it's a simple case of multiplying the numerator and the denominator by the denominator in the question. But for 3 stars, you have to multiply by the conjugate, which is just the denominator, but with the opposite symbol. So if this was a 6 plus root 2, you'd be multiplying by 6 minus root 2, which is the conjugate.